over this real quickly. So again, this is just the reminders of how we identify the fraction value for our points. So we have the point located right here. It's in between the 0 and the 1. So we need to figure out what each of these markings is going to represent. How many markings does it take to get from 0 to 1? Who can tell me? From 0 to 1, what are we counting by? Tens, right? It's going by tenths. So that means this is 1/10. This is 2/10, 3/10, 4/10, and so on and so forth. I can stop though because I've now found out what this marking is going to be. We're at 2/10. Now here's the thing though, 2/10 can be simplified, right? 2/10 can be simplified down to what value? Daniel? 1/5. So 1/5. So this marking right here is going to be 1/5. If you write 2/10, that's fine. Just make sure you know that you can simplify them just in case. Okay, so you count your markings. You count how many times it takes you. If we look, we will 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 jumps to get to the 1. So we know we're counting by 1/10. Okay, let's take a look at problem number 2. Problem number 2 is not by 1/10. What are we counting by here? From 0 to the -1, we're counting by how much? Esther? 5s, right? So that means that this is going to be a -1/5. Notice I'm putting negatives now. This is a -2/5. This is a -3/5, and then -4/5. -5/5 would just be the -1. So now we've got our value for this marking. This marking is -3/5. And remember when we're writing our negatives, you can write it either with the negative sign in front of the fraction, or you could write it as a -3/5, or you could write it as a 3/5. What happens if I write the negative on top and on bottom? Who remembers what happened? When we wrote it on top and on bottom, what happened to the value? Tayana? It changed it to a positive. So remember those things. When we're writing a negative, you can only have one negative sign, either in front, on top, or on the bottom. If you have it on both top and bottom, then it changes the sign to a positive. Okay, let's take a look at problem number 3. Problem number 3, we're trying to figure out the value of A. So how many jumps are we counting by? How many jumps are we going to count by for problem 3? Michaela? 4 of them. So that means that this is going to be a 1/4. This is a 2/4. This is a 3/4. However, look how we are past the 1. See here we have 0, and then 1, and then 2. So that means this is just 1/4, 2/4, 3/4. Then we've got 1 whole, and then that would become 1 and 1/4. Because we passed a whole number, that's important. Since we've passed it, that means we have to include it in the answer. So this value is going to be equal to 1 and 1/4. 1 and 1/4. Okay? And then for problem 4, to get from 0 to 1, what are we counting by? What are we jumping by? Thirds, right? 1/3. So we have 1/3, 2/3, 1 whole. Another 1/3, 2/3, 2 wholes. That's a 1/3. So this is going to be 2 and 1/3. 2 and 1/3, because we're passing a whole number. We passed the whole number, and then we landed on the fraction behind it, or next to it. Okay, so there we have our little warm up. Okay, we're going to have some questions like this again on your test because it was the most missed concept on the first test. So we want to make sure that you guys understand and remember how to identify those fractions. Okay, let's go ahead and turn to the back. where we're going to be working again on multiplication and division vocabulary. So as a quick reminder, a reminder of our multiplication terms, a multiplication and our division terms. Here's our division. So we want to make sure that we understand our terminology. Not right now. Okay. All right, so multiplication terms, we want to identify whether a vocabulary term will be multiplying or whether the problem will have us doing multiplication or is the problem going to have us doing division. Okay, and we're doing this with fractions and with decimals, those rational numbers. We already did it with integers. Now we're going to do it with some rational numbers. It's the same process, the same idea. So Dirk and Anita each made a bowl of punch. Dirk made 3/4 a gallon. Anita made 4.5 times as much. How much did Anita make? Okay, we have how much Dirk made. We have the fact that it says Anita made 4.5 times as much. So the fact that we have the words times, what does that imply that we're doing? Multiplication. Okay, we have the term times. Times means that we are going to go ahead and multiply. See, it's right here, times. So we know that we are taking how much Dirk made and we're multiplying it by 4.5 to find out how much Anita made. Okay, so for here, 3/4 of a gallon, we're going to multiply it by 4.5. Okay, 3/4 times 4.5. Go ahead and do that into your calculator. 3/4 times 4.5. You're going to get an improper fraction. You need to know how to convert it to a mixed number as well. Who can raise their hand and tell me what is the improper fraction going to be? Tayana? Huh? Okay, so that's the mixed number. That's the mixed number. What's the improper fraction first? 27/8. So 27/8, and then she already converted it into a mixed number. Okay, 8 goes into 27 3 whole times. Right? 8 goes into 27 3 whole times. 8 times 3 is 24. So if we take 24 away, we're left with 3 remaining. Oops, that should be out of 8. So we can have 27/8, or we can have 3 3/8. Either one of those is perfectly fine. 27/8 or 3 3/8. Okay, so we are multiplying because of the terminology times. Okay, at the end of the night, a pizza place has 2/3 of a pizza left over. The 4 employees each took home an equal amount. How much did they each get? They each took home an equal amount. How much did they get? What are we going to do? Are we going to multiply or divide? Divide, right? Because of the fact that they're splitting it into those equal parts. Remember the terms equal parts or equal groups. Equal parts or equal groups means division. So we want an equal amount. An equal amount for them means that we're going to go ahead and divide that. Okay, so we're taking how much pizza we've got and dividing it amongst the 4 employees. So we're going to take the 2/3 pizza and then we're going to divide it amongst those 4 employees. Okay, so right now in your calculator, go ahead and do 2/3 divided by 4. 2/3 divided by 4. Daniel, what did you get? 1/6, right? It's going to come out to 2/12, which would then simplify to 1/6. So they're each going to get 1/6 of the pizza. They're each going to get 1/6 of the original pizza. All right, let's take a look at problem number 3. A sandwich is 4 3/4 inches long. Mary eats 3/4 of the sandwich. So how much did she eat? So this is a word that we haven't really talked about much. The word of. And I'm going to go ahead and highlight it in blue so that I can tell you right now it's a fraction, or I mean a multiplication. Whenever you have a fraction and the word of, if you've got a fraction and the word of, that's implying that you're going to multiply. Okay? A fraction and the word of is going to represent multiplication. So let's write that down under our multiplication portion right up here. If you have a fraction of, if you've got a fraction of something, a fraction of something, that is another term for multiplication. So write that down under multiplication in parentheses or in quotations, fraction of. So it could be any fraction. It could be half of. It could be 3/4 of. It could be 2/5 of. That means you're going to take your value and multiply it by that fraction. Fraction of represents multiplication. So it's really important for you to understand. A fraction of means you are going to multiply in that problem. Okay, so let's take a look at the problem here. So again, the sandwich that we have is 4 3/4 inches long. Mary is going to eat 3/4 of that sandwich. So we're going to take the length and we're going to multiply it by 3/4. Go ahead and put that into your calculator. Do 4 3/4, and you're going to multiply it by 3/4. You're going to get an improper fraction first, then you'll get a mixed number. Who can raise their hand and tell me what is the improper fraction going to be? Go ahead, Jeremy. 57/16. Good. All right, 57/16. Now, to convert it into a mixed number, how many whole times can 16 go into 57? Daniel? 3. Okay, 16 can go into 57 3 whole times. If we do 16 times 3, that gives us 48. We take 48 away from 57, we're going to have 9 left over out of that 16. Okay, go ahead and get that copied down, and then let's go to the back page, or the last page. All right, I want you guys to try problems 4 through 8. 4 through 8 on your own. I want you to do problems 4 through 8. You're going to identify if it's multiplication or division, and then you're going to work the problems out. You can use that calculator. All right, so for problem number 4, a painter has 16 3/5 pints of paint. He needs to paint 4 1/5 rooms. How much paint is he using for each room? Are we going to multiply or divide? Divide. Okay. If you remember, we talked about it before, that if you have the word per, each, or every inside of the question, if you have per, each, or every inside of the actual question, then that means you're going to be doing division. So you're taking the total amount of paint that the painter has, you're taking the amount of rooms that the painter needs to paint, and you're dividing them. Okay, so you're splitting the paint into equal parts to be able to paint each of the rooms. Daniel, turn around and focus. So we're going to take 16 3/5, and we're going to go ahead and divide it by 4 1/5. Okay, 16 3/5, and we're going to divide it by 4 1/5. Who can tell me what they got? Go ahead, Eileen. 83 over 21. Good. So 83 over 21. Now, 21 can go into 83 3 whole times. Okay, it can't go into it 4 times because if we did 21 times 4, that's 84. That's too much. Okay, so it can go into it 3 whole times. So we have the 83 minus, we're going to do 21 times 3, which is 63. So 83 minus the 63, that's going to leave us with 20 left over out of the 21. Okay, so either of those is an acceptable answer. Again, the fact that we had the word each inside of the question is going to imply that we are dividing in the problem. Okay, number 5, Mrs. Matthews buys deli meat for her kids' lunches every week. She buys 3.75 pounds of ham. She's going to use 0.25 pounds for each of the sandwiches. Then how many sandwiches can she make? If she's going to use 0.25 pounds of ham for each sandwich, then how many sandwiches can she make? Are we multiplying or dividing? Dividing. You're taking how much total ham and how much it is per sandwich, and you're going to divide them to find out the total number of sandwiches that she can have. Okay, so we're going to do 3.75, and again, it's got that word each inside of the question. It's inside the question. So we're going to go ahead and do 3.75 divided by 0.25. Okay, so 3.75 divided by 0.25. What do we get? 15. So we can make 15 sandwiches. We can make 15 sandwiches out of the amount of ham that we have. Okay, problem number 6. Marathon Digital Movies is having a sale. Customers can download 13 movies for $15.99. So 13 total movies is going to cost them $15.99. So how much does each movie cost? What operation are we doing? Division. We are dividing. Okay, all 13 together is going to equal a total of $15.99. We want to know how much is it going to be for just the one, right? And again, the word each is inside of the question. It's inside of the question. That means that it is going to be division. So we're going to take the cost, $15.99, and we're going to divide it by the 13 movies. So $15.99 divided by 13 movies is going to cost how much per movie? Huh? Now you got to take $15.99 and divide it by 13. You did 13 divided by $15.99. $1.23. $1.23. Okay, each movie is going to be $1.23. Okay, Jasper plans to serve cheese and crackers as an appetizer at his next dinner party. He buys 0.8 pounds of cheddar cheese. The cheese costs $5.35 per pound. So how much is he going to spend? Okay, this is how much he is buying. This is what the cost is per pound. How much is he going to purchase? Or like, how much is it going to cost him? What are we going to do? Don't even worry about it as you know, decimals or fractions. Think about it. If I say, hey, you're going to buy 2 cookies and each cookie costs 25 cents, how much money are you going to spend? You're going to buy 2 cookies. Each cookie is 25 cents. How much is it going to cost you? 50 cents. What did you do? You multiplied those values together. You took how much you were going to buy, what the cost is per item, and you multiply it. That's how you figure out how much you're going to be able to spend. This is a multiplication problem. How much of it we're going to buy and at what price we're going to buy it at. So we're going to multiply it by the $5.35. Now that's per 1 pound. We're obviously not buying an entire pound. How much is it going to cost us? $4.28. Good. Okay, and then our last problem. Andy bought 18.5 pounds of fruit for a class party. The class ate 2/5 of the fruit. How much fruit did they eat? Now here is a reminder again. 2/5 of. What did I say happens if we've got a fraction of? multiply. If we've got a fraction of, that right here is going to imply multiplication. We are going to take 18.5 and we're going to multiply it by 2/5. So 18.5 times 2/5. Okay, what is that going to come out to? 7.4. So we're going to get 7.4 for our answer for the last one. Okay, what you're going to be doing today is you're going to go to Google Classroom, and there is a Delta Math link that you're going to work on. You've got the Delta Math to be able to work on for today.